Hello, welcome everyone to our webinar today, and thank you for joining us. Today we're going to be looking at the International Baccalaureate and how TI Nspire can help students through that course. During this webinar, if you're having any trouble hearing me, then you can adjust the sound using the communications menu. Make sure that the mute is not on. The mute is the one just down here, or you can adjust the volume. Best not turn up too loud. The other thing you can do if you're not hearing us at all is there's a 1-800 number there. If you've got a pen, you can write it down as 1-800-708-203 and just use the meeting number. It will ask you to use the pound key, which for us is the #1 on your phone. So you can use that one. And we'll assume that everybody is hearing this because I can't see any complaints coming in at this stage, so that's good. And if you want to communicate with us in other ways, I can always send that information back out to you using the chat space. There should be a little green bar at the top of your screen that says Viewing Texas Instruments DES. Well, that's what it says on mine. It should really say Viewing Texas Instruments Desktop, but the little green bar is a bit short. And you can use that to bring down the chat space, and you can send stuff to myself or any one of the presenters. And how do people hear about these hear about our webinars and other items of interest is by signing up to our e-newsletter. So if you haven't already done so, then it's free, and please forward that information to your fellow staff members so that they can hear about these events as well. We're also trying to promote local conferences. The Mathematical Association of South Australia has their annual conference coming up on the 24th and 25th of April. So if you're in that part of Australia, then by all means log on to their website. Now today I'm being joined by Bajana Graham. She is has a wealth of experience in IB, as you can see by her information there. But what people may not know is that she is an amazing mathematician and always manages to provide an extremely clear and succinct explanation of mathematical concepts. And our other panellist tonight is John Baymont. He's from the Northern Territory, and as you can see, I've ad-libbed a little bit on his hobbies there, the fact that he enjoys wrestling crocodiles. He assures me he wants that one taken off, but it's there to stay for now. And what you may not know about John is that if you've never been to one of his workshops, they are absolutely fantastic because he, for me, provides an amazing amount of enthusiasm in his workshops. So I look forward to hearing from him tonight. I know we've got some administrative sort of stuff that he's going to talk about first, but then we'll get stuck into the mathematics. The administrative stuff being to do with the sorts of modes and press to test and that sort of thing that you need to set up for exams. So, without any further ado, I'm going to pass on to John. Are you there, John?
I am indeed. Good evening, all.
And I'm just switching over to you. And you're there, Bajana?
Yes, I am. Good evening.
Very good. All right, so John's going to lead us off, and I believe you're going to talk to us a little bit about the sort of settings people should have on their calculator, as well as press to test. Is that right, John?
I certainly am. Thank you, Peter. As I said already, good evening all.
And it's coming through loud and clear. Thank you.
There we go. Thank you. So your students in their first year of the IB diploma program may have come with various calculator experiences, some having used the TI Nspire CAS and others having never seen a TI Nspire TX non-CAS. It is important to be aware of the differences and the fact that in the IB diploma program, the non-CAS version must be used. As the omission of the word CAS suggests, the main difference is the lack of computer algebra system. This affects several of the menu options which I've shown in this document, and I have linked this to the webinar, with the main impact obviously being on the algebra section, where there are only 3 options available compared to 13 on the CAS version. And we can see that the options are here: numerical solve systems of linear equations, and polynomial tools, which leads us into find roots of polynomials, real roots of polynomials, and complex roots of polynomials. So if we look at a non-CAS calculator, we can still define functions, just like on the CAS. and we can still calculate values within that. Notice that when I press the F, it goes bold because it's already assigned to something, and we get the answer of 13. 3 times 5 minus 2 is 13. But unlike the CAS, it wouldn't do. Tells us that the variable is not defined. And what it means here with the stored is that we could store A as a value, but really that is no different to just using this functionality here in the first place. We can do the same with quadratics or any polynomial. Notice again when I use define, it goes from italic to define, which means that it's used as something. We use 1x minus x squared. That again is defined. And in the algebra section, if we wanted to solve that, we could solve it for actual values, again. But if we were wanting to solve it in numerical solve, in algebra, this can be done, but Vijana will talk more about this later on. As you can see, we can solve systems of linear equations, if for example, just here, and typing it into the box that's already created for us. If I type in 3x minus y equals 2, and x plus y equals 1, it will simply solve those linear equations for us. Very nice, very much like the Polysim 2 app on the TI-84. Now this is only for linear and does not work for quadratics. If I try to add squared in here, change the second one to a quadratic, the calculator does not like it and says, hang on a minute, we can only solve it in linear equations. With the non-CAS version, obviously the students would have to rearrange those into y equals, graph both of them, and then use intercepts in the graph mode to actually solve them. A nice little touch is that you could also, in the algebra section, is change it rather than from x and y to use words. This will work exactly the same. So if we had 3 apples, make sure you type it in, the word in exactly the same as you've used as your variable. 2 pears equals $6, and an apple and 3 pears equals $5.50. Again, it will work out the values just exactly the same, whether it be x or y. A nice little touch. And finally, the third option in our menu for algebra is polynomial tools. We can find the roots of polynomials in a more structured way. Or we can use real roots. For example, y cubed. Make sure we come back down off the cubed with respect to y. You'll find the roots. Now it's only finding the real roots there. Sorry about my dog in the background. And obviously there are others. There's 2 more. There are 2 complex roots. We could either go back into the menu and type in the complex, but I can, since I know what the syntax is for that, which is the same as polyroots but with a C in front, it will do exactly the same. And another way of doing the same calculation but perhaps in a different format, and I think this is quite nice to get students thinking about what those coefficients are, is we can actually type it in just as those coefficients with curly brackets. There's 1 for the cubed, none for the squared, none for the x, and 1 for the constant, and it gives us obviously exactly the same answers. So that was the first part of what I wanted to talk about, just to give us a bit of background. And the second part is talking about press to test. Now, press to test is a functionality that needs to occur when students are doing the exam. This document, again, a TI document I've included in this webinar. I'm afraid I can't show you how press to test works on my software, but this document is included in the webinar notes. And the default when you go into it is 10 of the restrictions in place. Those 10 don't need to all be on for IB. And again, this document will be available. These are the 10. These 6 IB expect you to have locked and disabled. And these 4 are allowed to be enabled. So we can still do our inequalities, we can still be involved with trigonometry in our logs, and what I've just showed you already with our polyroot finder and the simultaneous equation, those functionalities still work. Just bear in mind as well that when we are in press the test at the start with the angle settings, really for standard level and higher level, it's best to have this set in radians. For studies, degrees is only going to work in degrees. We don't need to worry about anything else. So degrees is fine for studies, but for standard level and high level, you want to be in radians. Then when you are working in the calculator screen, let's go Russell's way, I love this, and we're in the graphing screen, and you do want to have something that was in degrees, we can simply go into menu settings and change that from radians back into degrees if it wasn't already, which it wouldn't be. And if we are in normal calculator screen and we were wanting to do something with degrees, if it was in radians, let me just set it up. So if we were in radians, then we could simply go into trig. If we're using a trig function, it was in the radians. I'll just confirm that now, clarify that, sorry. And we did this. We can add the degree symbol. Now there is a degree symbol here and also within the pi. The downside of using this is that it will always revert back to the pi section on here. But if we use this one up here, it will always stay on whatever you've been using last, and therefore it will simply be able to calculate it. And I think that's a nice introduction. I think that gives you a flavour of what you need to be mindful of with the IB. And now over to a truly remarkable lady, is Vijana, and she will tell you more about some of the things that we can do with the Nspire to inspire our students in IB mathematics. Over to you, Vijana.
Thank you, John. Good evening, everyone. What I planned to show in today's session, in the first slot, I will talk about binomial graphs, binomial and Poisson graph. Binomials is both standard level and high level, and Poisson is just high level. So we look at how to create the graph of binomial distribution, and also how to put a slide and see how the graph varies when the p-value varies, and how to look at the mode, what is the mode of a particular distribution, and it can be seen from the table or from the graph. When marking exams, we notice that many students really mix up the concept of mode, that this is the x value with the highest probability, and it probably needs some reinforcement. So let's see how we can actually create those binomial graphs. So if we open the spreadsheet, and I need to open actually, hold on, a new document, and list and spreadsheets, and I put n value here, and I will call this probability. So let's say I will have the binomial distribution with 10 trials. So I enter those 10 values. So 10 trials, and then if you want to enter the formula in the spreadsheet, you need to go to this region, and if you press equals, then we can go to menu, statistics, distributions, and we can find binomial PDFs. So we know that the number of trials is 10, and let's start with the probability of the success 0.2, and our n value changes, and we call it n, and we say OK. Notice that it's in bold because we already defined it here. If I press enter, it will ask me n is a column or variable. It clearly is a variable. So now I have created this table. And students can see from the table which X value here has the highest probability. Actually, I should call it X, probably would be better. And we can also present that on the graph. So if I have X value here and probability, we can see how those values change. And if you go in between the points, you can see that the highest probability here occurs for X value of 2. We can, of course, change those values of P, and if I change it to 0.9, so everything here will be overwritten, and then I can see in window, zoom, actually we'll do zoom fit, zoom data, so I can see that now my probability has moved to the point there. Something happened, I lost it for some reason. It usually
Just check
happens.
the values for Anne. You may have moved one of those points.
Yep, I guess so. So what we can also do, we can actually insert the slider, and then if we have the slider, we can animate the slider and see how the probability changes for those different values. And I show how to do it in a second. That works even nicer when our N value is higher, and that is something the students can visualize what happens when the probability changes and so on. So how do we do the slider? We would need to open a new graph screen, and then we would change the graph entry to scatter plot. And since I already have some values defined, I can take those values for the variables, and I will have some values for the probability which I had with in the scatter plot. But if you want to enter the slider, so I will call it P1 here, and then you change the values. Start with this value from 0.1, let's say, to 0.9. And you also have the option either do it automatic, but probably it's better to go every 0.1 here in the horizontal. And if you wish, you can minimize it as well and then set up the window. So if it is linked, as I said, to our P here, and we have now the scatter plot, so that's how those values will vary. So that is a good teaching way of showing how the mean varies for the binomial distribution, and we can do the same we'll try for Poisson distribution. So let's start a new document, because otherwise I will have all those variables. So I will call that X, and we'll have 0, 1, 2, 3, 4, and then here I will call it probability again, but this time I will use the Poisson distribution. So distributions and Poisson PDF, let's say the mean value 1.5, and the X value here is X. And if I enter again, I need to change it to variable reference. And that's quite interesting, again, to see what happens with the probabilities in Poisson. So the highest probabilities, as we see, occur for the values of X0 or 1. And then, of course, we can add more values as we go, and that will automatically recalculate. And, of course, those values will be smaller and smaller. And again, students can see what happens if we change this value. And it's quite interesting if I change it to, let's say, 2. And I can see that now I actually have 2 modes. And that can also be shown graphically. and probability. So clearly for lambda, I chose 2. I have 2 modes, and it's quite interesting just to play with those numbers so the students realize what happens if I put 3 here. Again, I can see how it looks graphically, and it is 2 again, but if my mean value is, let's say, 0.5, interestingly, the mean value is just a single value, which can be seen there for 0. And again, if students look at the table and they are to justify what is the mean value, they would say simply it is 0 because the probability is already 0.6, which is greater than 0.5. So, of course, any other has to be smaller. So that's one of the things. And also, looking at the numerical solve, let's consider this example that we have a binomial distribution, and for game B, we have the probability that Evan wins is P. He plays game B 7 times and find the probability that he wins exactly 4 times. So clearly, if we use the formula, we create this equation and solve 35x for 1 minus x cubed equals 0.15. And if we try to solve this equation using numerical solve, so clearly if I don't put any restrictions, P becomes as minus 0.22. So that's why numerical solve is tricky. So because it actually gives the value smallest to the origin, to 0. So of course I can overcome that and say, okay, but my P I know is greater than 0, but then it gives me only 1 value. I could play a little bit more. What if I put it greater than 0.4, gives me another value, but how many are there? So that's not the best way of doing it, and that's why it is really recommended that students use graphical solutions. So if we define those functions with P unknown here, and we put 0.15 as the probability, we clearly can see that when P is between 0 and 1, and that's the values P can take, there will be 2 solutions, and you get those two solutions from the intersection straight away without worrying about the P values. So there are a few nice activities on probability distributions, looking at graphs and looking at tables and talking about the mode values and doing some animation, and it's still moving. So that's the first activity I would like to show. So I will now go back to...
Just before you do move on there, Bojana, can
Yep.
we just go back to that Inspire document that you had open? And
Yep.
there's a couple of tips have come in. One from myself, and also one from one of our viewers, Russell.
Yep.
He was mentioning, recall when you had to choose whether it was a variable reference or a column reference.
Yes.
He was advising us that if we use the variable key, then it will automatically detect.
So you're saying
That's
that
a nice
if
shortcut,
instead of, if I use that.
Yeah, that's right. So if we use that, then it'll automatically detect, so we don't have to go
Okay, that's a good hint. Yeah, I always go through those steps, but yes, of course, if you forget what variables you have, you can go there, and if I want to see what variables I already have, I can see that these are the 2, and as you said, if I put it there using the variables, then it will not ask me the question, yes?
Yeah. The other one, which is the error that you got before, I suspect, because the binomial distribution is looking for n as an integer value, and
I know something happened there.
Realize that the dynamic nature of our scatter plots here, that you can actually drag points. So if you just want to put in a calculator page, that's it, and scroll down the bottom there, and type in lock, L-O-C-K, and then just leave a space and put in, yep, that's the one, and then put in your N.
Right.
And what that will do is make it, and you press enter, and then that variable will be locked. So what that means is if people try and move it accidentally on that interactive space that you had, then they can't disturb it. It's another nice way of making it so, in this case, if you want to experiment with stuff, you can only move things vertically if you lock up the horizontal variable.
Okay, excellent. Yes.
Yeah.
And if you have some data set for the kids, you send it, you lock the variable so they can't change it. Yes, that's what we do.
And of course, the next question someone's going to ask is, how do you unlock it? Well, you unlock. That's right. Yes.
Done.
That's it.
Okay.
Very good.
So now I will. Hold on, where do I go? Stop sharing. And I move it to John.
You there, John?
I certainly am. Thank you, Bojana. Always a pleasure hearing. Now I can't see. There we go. Pleasure hearing you.
Just while we're waiting for John,
and always learn many things. So thanks for that.
Just a reminder to participants, if you have any other comments or suggestions, as Russell had typed in and shared with us, that chat space. If you hover up to where it says Viewing John Damon's Desktop, you can use that chat space to send information to and from.
Yep.
Okay, it's over to you, John.
Thank you, Peter. So we'll now look at two more areas of the TI Nspire. We'll look at both the graph screen, and we'll also look at listed spreadsheet and scatter plots. To start with, we think, well, okay, where are we going to get some data or data from? As we know, depending on which part of the world you're from, you say it differently. Students may have collected their own data, but one of my preferred places, if we're looking for something a bit more general, is from the Australian Bureau of Statistics and the Census at School information. If you haven't seen this before, there's mainly three different types that you can access. One is samples that have already been prepared, which means that they've been cleaned, as we can see here, clean data, and also dirty data, which will have just random students' values in there that they may or may not be true.
And is that the real technical term, John? Dirty data?
Yeah, that's Russell's. I think it's Russell's one. I think, which I've always quite enjoyed saying. So yeah, that's the one. The other one is data for calculators, and we can see here we can either put it onto an Excel or a TNS file. If we go this way and we just choose a TNS file, and this works really nicely on the iPad, it will just open it straight up into the iPad. If we click on it here, it will open it straight up into our TI Nspire software document. And the other one that I would use for assignments with my students is the random sampler. This allows students to control the size of the sample and what information they collect in the year. They can collect up to 200 in each hit, and they have a wide variety of uses that they can collect here, options available to collect information from here. So for mine, I'm using the prepared samples that I would use in class when you want students all on the same page. You want them all to get exactly the same information, and I've already done one of those already. The Blue Peter Special, if you can. Oh, that's interesting. There we go. And here's one already with, as we can see, 40 students. So if I was looking at height and belly button height, one of the old favourites, I can simply copy that Excel document.
Now, just
open
like
up a listed spreadsheet
copying
page.
that Excel document, just to reinforce what he's doing there, because it's very handy also if you've got information that you've taken from the World Wide Web, be it a web page where the data's in a table. If you've got data in a table on a website and you really don't want to copy it out because there's a lot of numbers in there, I used one for my students once on the amount of water stored in Victorian dams. It was an interesting weighted average question because students had to pick up that the dams were bigger and therefore the percentage capacity was a different value when they're trying to work out the overall average. But it pasted nicely into Excel, and as John's demonstrating here, once it's in Excel, you can copy that and drop it straight into Nspire.
Thank you. So here we go. As long as I haven't gone into any of the cells, if I went in like that, it wouldn't work. I need it to be bold, and we'll simply paste them all in. Now, on the calculator screen, it looks a bit small. You can't see very many of the values, so it's much nicer to put it into computer view if you're using the software, especially with students. I've got the boldness set a bit bigger at 100, 150 to show you on this screen, but you could decrease it for students if you had a smart board that showed it a bit clearer. Oh, I was behaved before. That's a bit silly. There we go. Where we can see more values, but I'll leave it slightly larger for now. We obviously need to label these column headings. This one is height. This one is belly button height. And there we go. The data is now in here. We could straight away just do a statistical analysis of that by simply clicking on a free cell to the side. Silly me. Put in computer view. Down to statistics. Stat calculations. We're hoping that, or thinking that it may be a linear regression. We then need to think about what our lists are. Our X list, well, I'm going to choose a little bit more broad on this one. I'm going to choose my variable to be belly button height and my Y list to be height. I'll save that regression equation in F1. And we've only got one of each. And there we go. There's all the information that the students may need. So that is one way that the students can do it. We will then potentially want them to graph it. There's two ways to graph this. One way, and there's advantages for doing it both ways. I quite like the data and statistics page, but I like the students to picture that that is each individual. And if we hover over it, and especially if I had more data copied into that list and spreadsheets page, it would come up with much more information about them. But we can then click down here and add the belly button height. There's those students moving into a column graph, or a dot plot, shall I say. And there we have the students now moving to produce me a scatter plot. Now, thinking back to when I studied maths at school and thinking, well, I'd like to think it wasn't that long ago, but I'm sure it is now, well, students would say it was, we used to have to put in a line of best fits. And I think it's nice for the students to do exactly the same themselves here. So we can go into Analyze and they can add their own movable line. So the students can think about where do they think this line of best fit is. This helps them understand, especially over time, where that line of best fit is, how it works in relation to the regressions and the residual plots. So it's a nice idea for them to think about that. And when they feel that they've got it where they think, they can then go back into Analyze and they can actually see what the regression is and see how close they are. Quite nice, perhaps I nearly did it before, to change the colour of the one they produced. All the territory, there we go. And that was mine. And this is the real one. A little bit off. A nice thing to do for IB is to show that the mean of both the belly button height and the height lies on this line of best fit. To do this, we can go back into Analyze. We want to plot a value, and that value we want to plot is the mean of the belly button height. And there is our values for the mean of the belly button height. Now we're going to need to do the Y value, or the height. This time we're going to go into Analyze. We're not going to go to plot values. That will only do for X values, X equals. We want to plot a function and follow the same process. Mean, and I would like to say thanks to Russell for reminding me about this one, of height. And there we are. There we can see that they cross exactly on the line of best fits. I will show a little bit more on this one at the moment, but I just will add before that we can also do it in the graph screens. Again, there's advantages for doing it in both, and I think you should show the students both of them and let them see the advantages of working in both areas. We are going to do the same thing again, so we're going to go and put a graph in. We're going to put a scatter graph in, like Bajana did with the last activity. Our X variable, again, is belly button height. Our Y variable is height. And there we go. Oh, no, we don't. Always think that this is a useful activity for the students to go, where is it? They think it's broken or something's gone wrong. obviously probably not at diploma level, but definitely in the junior years they think that something's going to happen. But obviously they're looking at between -10 and 10, and -6.6 and 6 2/3 on the y-axis, and obviously the values are way up higher. So we did change the window. Either that can happen, I like students to do it themselves and actually choose window settings. So they have control and actually have thought over where those points are. I'm going to be lazy today and simply go, I want to do it in relation to the data. And there we go. We can then add our regression equation. Well, a nice little way to enter that would be going to functions. To do with statistics, we're going to type in stat, put a dot. We want the regression equation for x, and there is the regression equation exactly the same if the window is the same as on our other setup. Now the slight difference is this time, if we were wanting to do the mean of both the x and the y, we can do that slightly differently. For that, we're going to put a point on here now. So we're going to go to the geometry section, and we're going to go point. I'm going to put that point anywhere. And when we go on it, oh, I've forgotten. No, I haven't. I thought I'd press enter. Let me see. Why is it not coming up? Let's see.
I did think of another way while you were doing that, John, that if you went into your graph entry edit option, you can always plot an equation there and do it in the form x equals, I think, from memory.
Yeah, I want to get a point.
I had that using geometry
earlier. Let's just try that again. Let's just try that again. Let's undo that. And we've got our point. Press anywhere. Not letting me do it. There we go. Press the brackets when I'm over that point, and do exactly the same as it did on the previous screen. So we're going to do the mean of our belly button height for our x value. Enter. There we go. Panic over. The mean. Now you have to put brackets, close brackets around that height in a minute, of our height. Choose the variable just to make sure that we're okay. Alright. And I think it will give me error because I didn't put a bracket around it. So that's what messed me up. So let's go again. Here we go. Third time lucky. Mean, bracket, variable, belly button height. And I did it again. Oh, John, what are you doing, buddy?
That's because you practiced it, and this probably highlights what happens with students. If they practice the wrong thing, then that's what they will learn. So
belly button height.
Lesson to close
brackets. Here we go. Now we're on a roll. I see I'm flying now. Here we go. I'm not going to forget this one in a hurry now, neither will I. And there we are. And we can see that point has landed right here. All right, we can see that point has landed right on the line of this thing. And we can find the coordinates at that point, and there we are. So that's the mean of the belly button height and the mean of the height. And if we then go back to either screen, but if we were on this screen, a nice thing is, and let's find the value. What's that value there? 49,160. If I find 49 and 160, there we go. There's 49 and 160 just there. If I grab 49 and 160, we can see that as I move it, not only does the regression line move, the line of best fit, move, that the mean of both the height and belly button height moves, and all the values over here on both because it's a dynamic program, both the values on the spreadsheet page and on the graphing page move as well. And really nice to talk to students before you move it, what do they think is going to happen? What's going to happen to either the line of best fit or those horizontal and vertical lines of the means if I move it up, if I move it left, or if I move it diagonal. A really nice little function there. All right, that's half what I'm going to do. I'm going to now open up a new document, and I'm going to go into graphs. The graph that I want to type in, and I will leave it in calculator screen for something different this time. Got it on 200%. I want to type in a cubic.
Just like John typing in that cubic, an interesting question was asked some years ago when we were doing some work with dynamic geometry and posing the question, what constitutes a proof? Have we actually proven to students that that line of best fit will always pass through that mean point? Because they've seen it, and in the same capacity, does dynamic geometry actually prove something because we observe it? I think it's not really a proof, but it would certainly lead us to the suggestion that a proof could be formed.
And a very nice activity to do, again, if you have the iPad app in terms of, like this one as well, even more so, but the students actually physically almost touching the screen and actually feeling like they're in control of moving the point.
Yeah.
So we can see here that we have a cubic drawn this time. We're going to look at the tangent on that cubic. So, menu, geometry, points and lines, and there's our tangent. Here's our tangent here. Just going to escape that to get rid of factor in tangent. I like to extend the line so that I can see it. We can see there's the equation of the tangent straight away. Obviously the gradient of the tangent or the instantaneous rate of change at that point on the cubic. And I like to talk to students about what this 20.97 means. Some of them don't quite understand or aren't quite clear what that is, so we could actually talk about how that is with the tangents. It is an intersection of both the y-axis and that tangent, and those coordinates obviously match. I thought I said 14 for a minute, I was a bit worried. There you go, they obviously match. This is really nice to talk to the students of how, when we move it around, both positive and negative and increasing and decreasing at increasing and decreasing rates, we can find the slope of that line in measurement. Again, either using the equation or keeping the two separate and just talking about the points. The advantage of using the points is that we can add variables to both these two if we needed to. Let's get out of that. And again, we can talk to the students what's going to happen to this number when I pull it down, what happens at the bottom, why does it go more negative, that's the right terminology, and then less negative, what's happening around here. The last thing that is a nice thing, now obviously we can actually graph the derivative if we wanted to, by simply typing it into either into here or into the normal calculator screen, the derivative, and then copying it across, defining it as a function. But before that, I quite like the students to produce a graph. So what we're going to look at is we want the coordinates of that point. Here we go. And we obviously need the x value. So we're going to, nothing there. I know, there we go. Store it as a variable. So let's call it the x variable of my tangent. And we also want to store the gradient of that tangent. So again, we'll store that as the gradient of the tangent, aptly named. I want to add another screen. So you can go many different ways. Add a page, list in spreadsheets, and we want this one to be the x value, and this one to be the gradient of the tangent. Now, we're going to now do live data capture on this. This will allow us to record the points automatically from the previous screen, and the variable that we're doing for the x value, well, that is our x value of our tangent, negative 1.92. Let's just check. Yes, it is. Cool. We're going OK. And we're going to do live data capture of our gradients. and we can 5.19, and yeah, it's been rounded off there, but it's the same. Once we've run that, we can go back to our graph screen, go into menu and add a graph entry of a scatter plot, and this scatter plot will now be the x value, obviously on the x, and on the y axis will be the gradient. Nice to talk to the students again. Where will that dot go when I press enter? There it is. You can change the color so that it doesn't clash with the other ones. And there we go, smooth that out of the way. And again, talk to the students that when I grab this point here, what's going to happen to these dots. And we can see that the gradient, which is the derivative of that cubic, gives me a nice quadratic curve. I could then match a regression equation to that and see that the derivative is actually a line of this. Or I could type the derivative into the calculator screen and dump it into the function. And on that note, wanting to leave 10 to 15 minutes for Vijana, I will stop there.
If
Vijana,
I can
I'll back to you.
jump in there as well.
Before I move back?
Yeah, can I just jump in there as well? I'll show you. I was just playing while you were doing that, John. So I'm just going to show participants something else, and then we'll go across back on to Bajana. This one was shown to me at a conference some time ago. Let me just share my desktop. My computer's a little bit slow. Apologies for that, folks. This one was shown to me at a conference some time ago, and just these small changes that we can have in the way that students are actually perceiving things. So you notice John put the point on the curve and drew the tangent. This is a very, very small variation of what John did. In this case, the point was put on the x-axis, and the only reason for doing that was because physically I was finding it difficult to move the x value at a constant rate. So seeing a small change in x, and often it sort of flew along. The other thing that's interesting is it allows students to keep their focus on the actual tangent line itself. So, for example, at the moment, that tangent line is rotating, if you like, in a sort of a clockwise direction, and then at some time later, it's now rotating in an anti-clockwise direction. And then it draws students' attention to somewhere in here, it changes from rotating clockwise to rotating anti-clockwise. They can also look at the gradient of that tangent line, and in this case we can say that that number is decreasing, and even when we go past that turning point, the number itself is still decreasing. And it's not until we get along here somewhere where the number starts increasing again. And that lines up nicely with the graph that John produced, where he was showing the derivative occurring at the same time. And as a nice teaching moment, it's also very handy to have students come out, if you've got this presented up on the board, is to have students come out and sketch where they think the derivative is going to land. That's a nice little tip as well. All right, sorry for the interjection, folks, but I'm now throwing the presentation across to Bajana again. You there, Bajana?
Yes, I'm here. Thank you. That's very nice what you showed indeed. So, share my desktop. And
we're good to go.
So what I would like to talk about is the advantage of defining a function as a piecewise function, because it is then recognized as one function and you can do values, integrals, derivatives, graphs, areas, tables, and everything. So that has applications to kinematics and continuous probability distributions. It is much better than, like students sometimes try to say, it is something given that x is between and something else when x is something else, and then it doesn't do what they want. So piecewise function has really lots of advantages. And because we are running out of time, I won't be showing everything by hand, but if we define, so we're looking at this kinematics problem again here, particle moves in a straight line, and the velocity varies according to this rule, a quadratic, 4, 0, 3, and then linear. find the distance traveled by the particle from its initial position until it comes to rest, and then find the time taken for the particle to return to its initial position. So if we define this function using the piecewise function, and that can be found here, and you just enter the values, and the syntax is very easy. So what we can do, we can basically find the value of the function at any point where it is defined, and then we can sketch it. So what you do here, you just change, I have a few things here, but what you do, instead of graphing V in T, you graph V in X, and that's our blue graph. Then we can get the point where it is cut the x-axis, and we can find the area until it stops by using menu Analyze Graph and Integral. What I did, so that answers our first question. What we can do next, we can define F2 as the displacement between 0x, F1 in X, and that shows this graph. And if we get the point of intersection when F2 cuts the x-axis, we actually answer the question, find the time taken for the particle to return to its initial position. Also, you can show the students that if you press Ctrl-T, you can see the table of values, and that's quite interesting to look at those values, particularly if we want to see what happens to velocity and displacement. And also it has the advantage that if I enter it as the absolute value of x, then I can find the area, the distance traveled up to 6 seconds by just shading this area. So that is quite a nice activity. And the other one which applies to, that's not what I wanted. Which applies to that is I need to open it through. I have to close it because that doesn't like the to open.
Yeah, unfortunately, we've got to wait for that one to go away.
I know. Oh, dear.
What I'll just explain for participants what's happening is that depending on the TI Nspire document, it will open in either the CAS or non-CAS version. So it is capable of doing both, depending on what functionalities in it.
So the other bit here is looking at continuous probability distributions. So let's have a look at this variable. It's a quadratic between -2 and 0, a quarter, and 0 otherwise. And what we want to find the mean of the function. So if we define the function, we can check that it is a probability density function, looking that it's actually equal to, the area is equal to 1, and then we can graph it using the same way. And if I want to actually find the median value, I can check the first area is up to here, and the numerical solve does work on a calculator here if I want to find the median solving by looking at this particular area. But you could also play with the table just as the learning area for the students. If we do the similar thing we did by sketching another graph from -2 to x, F1 in x, and changing how much the x values vary, you can clearly see that the median value will lie somewhere between -0.2 and -0.15. So it's a nice teaching strategy showing them what actually happens and how you can get that from the table. And that's where we are trying to get half the area. So I think we're running a little bit out of time. I still have the chi-squared, but I don't know, do we have more time, or we rather finish at this point, Peter?
I think we've covered quite a lot. If participants want to ask us some more questions, they
some
can,
more questions, so thank you.
They can always request that we do another IB webinar, because we do have some spots in our program next term. So we're certainly happy to run some more sessions. I know there was a workshop on this evening, which will have competed with some of our participants.
Yep.
All right, so let's wrap it up there then.
Back to you. Do you want? Yes. Thank you very much, everyone.
Thank you, Bojana. Thanks.